Welcome to the debate. If you look at the state of fundamental physics today, you have to admit something. Uncomfortable. We are stuck. We have been stuck for about 50 years. We have these two incredibly successful rule books, general relativity for the stars and galaxies, and quantum mechanics for atoms and particles. And they fundamentally contradict each other. They hate each other. Today, we're looking at a proposal that suggests the reason we can't make them fit is that we're looking at the board all wrong. We are asking, is the universe made of particles moving through an empty void? Or is space itself a living, breathing, 12-dimensional rotational geometry where matter and force are just different angles of the same thing?
That is a massive question. And, usually when I see a paper claiming to rewrite the nature of the vacuum, my skepticism alarm, it just breaks the knob off. I generally prefer the shut up and calculate approach. But we're looking at supersymmetric geometric quantum mechanics, SGQM. And I have to admit, even as a skeptic, the rigor here is, well, it's distinct. It's not just philosophy. It's a dense mathematical framework that actually tries to derive the constants we usually just have to measure.
It is. And for everyone listening who follows the theory of everything hunt, you know the stakes. We usually try to glue the standard model and gravity together by, adding tiny vibrating strings or pixelating space into little chunks. SGQM just takes a hard left turn. It suggests that the vacuum, the empty space between you and me, isn't empty at all. It's a 12-dimensional manifold.
Which sounds like a lot of dimensions. When we start throwing around 12D, people tend to tune out.
It sounds like sci-fi, I get it, but the core argument I'm going to make today is that this model offers the only geometric unification that actually works. My position is that by replacing the concept of propagation, things traveling through space, with synchronization, we solve the paradoxes that have broken physics for half a century.
And that is exactly where I'm going to push back. I'm representing the consensus view here. The standard model is the most tested theory in human history. General relativity works to precision levels that are just mind-boggling. So I am deeply skeptical of this non-propagation hypothesis. You're essentially claiming that light doesn't travel and gravity doesn't wave. And that contradicts, our daily experience and centuries of data.
I accept that challenge. It does sound counterintuitive, but I think I can convince you that what we perceive as travel is actually a trick of the light. Quite literally. Let's get into the position statements.
Lead the way.
So, let's start with the Aetheron itself. In this model, the physical vacuum is a structured lattice. It's a 12-dimensional rotational manifold governed by spin-12 symmetry. We call this the Aetheron. Now, the math relies on something called the SGQM invariant, or the Aetheron theorem.
Break that down. Is this some complex tensor equation?
It's actually surprisingly clean. It's essentially the Pythagorean theorem applied to reality. The equation is alpha squared equals mu squared plus E rot squared. That's alpha 2 equals mu 2 plus E LRT2.
Okay. So we have a right angles triangle.
Exactly. Visualize it. The hypotenuse is alpha, or alpha. That is the conserved rotational magnitude of the vacuum. That number never changes. The two legs of the triangle are mu, which is mass, and E rot, which is rotational energy.
So you're saying mass and energy are just sides of a triangle?
Precisely. They are orthogonal geometric projections of a single unified state. If you rotate that triangle in this 12-dimensional space, mass turns into energy, and energy turns into mass. And this is the key insight. It removes the separation between matter, the fermions, the stuff we are made of, and force, the bosons, the stuff that glues us together. In SGQM, they aren't two different breeds of animal. They are just complementary components of one unified geometric state.
I will grant you, visually, that is elegant. Unifying fermions and bosons through pure geometry. That's the holy grail. But here's my issue. We found the Higgs boson. We have detected gravitational waves that seem to travel across the entire universe from colliding black holes. My position is that the standard model works. We don't need a 12-dimensional manifold unless it predicts reality better than what we already have. So, does this actually fix anything, or is it just a prettier way to write the same math?
I believe it fixes the fundamental breaks. specifically the singularities in black holes and the measurement problem in quantum mechanics. It stops us from needing renormalization, which, let's be honest, is basically a math trick to get rid of infinities.
Those are big claims, but the burden of proof is on you. And specifically, I am just hung up on this non-propagation hypothesis. We measure time delays. We see light taking 8 minutes to get from the sun to the Earth. If I send a signal to a rover on Mars, I have to wait. How can any theory claim that light and gravity don't travel? To me, that sounds like abandoning causality.
It redefines causality. It doesn't abandon it. But you're right to focus on this. This is the hardest hurdle to get over because our brains are just wired to think in terms of objects moving through a void.
Right. If I throw a baseball, it travels. Why is light different?
Because light isn't a baseball. In SGQM, electromagnetic and gravitational phenomena are not waves moving through the lattice like a fish swimming through water. They are dynamic resonances. They are instantaneous local phase resynchronizations of the lattice itself.
Instantaneous local phase resynchronization. That is a mouthful. And it directly contradicts the fact that we see a delay.
We observe a delay, yes, but the source material uses 4 specific analogies to explain why we see a delay even if the actual mechanism is instantaneous. I want to walk through these because they really bridge the gap between the math and our intuition.
Okay, let's test them. I want to see if these analogies actually hold water. What's the first one?
The first is the waterbed analogy. So imagine a massive water-filled mattress. If you push down on one corner, what do you see?
A ripple moves across the surface.
That's what your eye sees. But physically, what is the water doing? The water is incompressible. To accommodate your hand pushing down, the entire volume of water re-equilibrates. The pressure field adjusts globally and practically instantly. The ripple you see is just a surface effect. It's a symptom of that global adjustment settling down.
Okay, I follow that. The pressure change is global, the wave is a local symptom. But that works for a contained volume like a bed. The universe is a bit bigger.
That leads to the second analogy, the rigid bar. In general relativity, we usually describe space like a rubber sheet, or maybe a spring. If you pull one end of a spring, the tension travels coil by coil. That takes time.
Right, that's the propagation delay.
Exactly, but SGQM says the Aetheron is geometrically stiff. It acts like a perfectly rigid bar. If you have a theoretically perfect rigid rod and you push one end, the other end moves instantly. The entire geometry reconfigures as a whole unit.
In theory, sure. But we know in relativity, even a diamond rod can't transmit information faster than light. You push one end, and the compression wave is limited by c. If that bar is light years long, the other end doesn't know you pushed it for years.
And SGQM agrees, and this is where the third analogy comes in, and this is the one that really clicked for me. It's the net and the metronomes. This explains the delay without losing the global connection.
Okay, paint the picture.
Imagine a vast elastic net stretched across a massive room. At every single intersection or knot in the net, there's a metronome, a little detector, ticking back and forth. All the metronomes are ticking in perfect synchronization.
Okay, I'm visualizing it, a field of ticking clocks.
Now grab one corner of that net and twist it. Because of the tension connectivity, that tension redistributes through the entire net instantly. The geometry of the net changes now.
Okay, so the shape of the universe updates instantly.
Correct. However, the metronomes are physical devices. They have inertia. So each metronome has to feel that change in tension and adjust its ticking rhythm. A metronome near your hand feels the twist strongly and changes its beat very quickly. A metronome far away feels a subtle shift and takes a little longer to fall out of sync.
I see where you're going with this. So the tension change is global and instant, but the reaction of the detector is sequential.
Exactly. The delay isn't the travel time of the tension. It's the phase lag of the local detector adjusting to the new global geometry. It creates the illusion of a wave traveling from A to B. But actually, the whole net shifted, and the metronomes are just catching up in sequence.
That is a compelling distinction. It preserves the observation of a delay, which, satisfies my skepticism about measurement, without requiring a traveling packet of energy.
Right. It explains the what of the delay without the how of a particle flying through the void.
But I still have one major hangup, the speed of light, c. In standard physics, c is the speed limit of the universe. In your model, if the net moves instantly, why is c always constant? Why is it 300,000 kilometers per second? Why not instant?
This is the fourth level. Synchronized pendulums. If you have a field of pendulums and you want to shift their synchronization pattern, there is a limit to how fast you can register that shift. The advocate here argues that c is not a speed limit for the Aetheron's geometry. The geometry is non-local. C is the sampling rate.
The sampling rate? Like a monitor refresh rate?
Exactly. It's the synchronization rate required for the 4D projection, our reality, to register the shift. We are viewing a 12D object through a 4D lens. That lens has a refresh rate. That refresh rate is c.
So c is the refresh rate of the simulation, essentially.
If you want to use simulation language, yes. It's the maximum update speed of the local reality.
I'm not entirely convinced by that line of reasoning. It feels a bit convenient to call our fundamental constant a refresh rate. But let's assume for a moment the geometry works. What is this geometry actually made of? You mentioned a 12-dimensional manifold. That implies structure. Is it just empty math, or is there something there?
It is very specific structure. It's built of Aetheron knots.
Knots. Okay, explain that.
So, in this model, particles, electrons, quarks, you, me, we are stable topological excitations. We are knots in the lattice. But we aren't static knots, we're defined by rotation. And this is where the math gets really fascinating about these rotational cycles. The paper focuses on two specific cycles, 720 degrees and 1440 degrees.
I saw those numbers. Usually a circle is 360 degrees. Why are we spinning things 720 degrees?
This is the genius of the geometry. Let's look at the 720-degree cycle, or 4 pi. In quantum mechanics, we know that matter particles, fermions like electrons, have spin 1/2. That means if you rotate an electron 360 degrees, it doesn't look the same. It's actually inverted. You have to rotate it 720 degrees to get it back to its original state.
Right, that's standard spinor physics. We usually explain it with the twisted belt trick or the cup trick. You hold a cup of coffee, rotate your hand 360, your arm is twisted. Rotate another 360, your arm is straight again. We just accept it as a weird property of matter.
Exactly. But in standard physics, that's just a property we measure. SGQM explains why. It visualizes this as 8 90-degree orthogonal flips of the Aetheron square's vertices. The Aetheron has to realign its mass axis and its energy axis. It takes 2 full rotations, 720 degrees, to realign the spinor identity. That sequence defines matter.
Okay, so 720 degrees defines a matter particle. I can accept that. It matches standard quantum mechanics. But the notes mention a 1440-degree cycle. That's 8 pi. Why do we need another cycle?
Because 720 only resets the matter, the fermion. But remember, the Aetheron is unified. It contains both matter and force, the boson. The 1440-degree cycle is the metacycle. It is the minimal rotation required for both the fermion and the boson to return to the initial configuration simultaneously.
So it's like 2 gears of different sizes?
Exactly. Imagine a small gear and a big gear. The small gear, matter, might reset every 2 turns, but the system isn't really reset until the big gear, force, also lines up. That happens at 1440 degrees. This is the definition of supersymmetry in this model.
And does this explain why we don't see particles with just random masses?
Yes, this solves the mass gap problem. The mass gap is the question of why particles have mass and the vacuum doesn't. In SGQM, it's a binary state. Either you complete the knot, the full closure, and you are a particle, or you don't, and you are vacuum. There is no in-between.
That is interesting. It imposes a geometric constraint on existence. If you can't tie the knot, you don't exist as matter.
Precisely.
Okay, let's zoom out. We have non-propagation, we have Aetheron knots, we have these massive rotational cycles. But this theory calls itself the champion. It claims to beat out general relativity, string theory, loop quantum gravity. That is a bold claim. So I want to stack it up against the heavyweights. Let's start with general relativity, GR.
We all know GR breaks down at the singularity. Black holes, the Big Bang, GR predicts infinite density. That is a math error. It means the theory has failed at that specific point.
Right, we usually just assume quantum gravity will fix that eventually.
SGQM fixes it now. It says there is no singularity. As curvature hits the Planck threshold, the manifold simply rotates into higher dimensions. It is a topological phase transition.
Like water freezing to ice?
Exactly. When water freezes, it changes structure. It doesn't shrink to zero volume. The Aetheron folds. No zero volume, no crunch. The math stays finite.
Okay, that is cleaner than a singularity. What about string theory? String theory has been the leading candidate for decades. It has extra dimensions too, 10, 11, sometimes 26. Why is SGQM better?
String theory has a massive problem called compactification. They have to claim these extra dimensions are curled up so tiny we can't see them. They're essentially hiding the math in the basement.
And SGQM's dimensions aren't hidden?
No, the argument here is that they're explicit. We have 4 external dimensions, space-time, and 8 internal dimensions, but they aren't somewhere else. They are the axes of spin, charge, and mass. When an electron spins, it is rotating in those extra dimensions. We interact with them every time we use a magnet. They are right in front of us.
I see. So instead of hiding the dimensions in a subatomic basement, it says, spin is the dimension. That is philosophically more satisfying. What about loop quantum gravity, LQG? That's the other big contender.
LQG says space is pixelated, little discrete chunks. SGQM says no. The Aetheron is a continuous resonant medium. It's like a guitar string. The string is continuous, but the notes it plays are discrete. Quantization is just the standing wave, the harmonic, not the string itself.
That is a crucial distinction. It keeps the smoothness of relativity but gets the quantization of QM. Now, I have to ask about geometric unity. Eric Weinstein's work. It sounds similar, geometric, high-dimensional.
It is similar in ambition, but the details matter. Geometric unity uses a 14-dimensional manifold. SGQM specifies a 12-dimensional manifold, M12. And here's the kicker. SGQM argues that 12 is the precise number needed to derive the fine structure constant, alpha. In SGQM, alpha isn't just a random number we measure. It's a dynamic synchronization factor. SGQM derives the number. Geometric unity has to input it.
That derivation of the fine structure constant is the holy grail. If that math checks out, that's a mic drop. But we can't talk about a theory of everything without talking about the elephant in the room, dark matter. Does the champion have an answer for the invisible stuff holding galaxies together, or do we need to invent a new particle?
It does, and this is one of my favorite parts. It is not some new magical particle we haven't found. It is a dark knot.
A dark knot.
Remember those rotational axes? SGQM says standard matter uses specific axes R1 through R4 and couples to light via axes R2 and R6. A dark knot is a stable rotational state along orthogonal axes, specifically R5, R7, and R8.
So it's spinning in a direction that light physically cannot grab onto?
Exactly. It curves the geometry because it has tension. But it is geometrically forbidden from interacting with the electromagnetic coupling axes. It is invisible, by design, not by accident.
That is a very convenient answer, but it's also very difficult to disprove. And that brings me to the most important part of this debate. Science isn't about pretty math. It's about testing. Is this just philosophy, or can we break it?
This is where SGQM separates itself. It offers falsifiability. It makes specific, high-impact predictions.
Give me the strongest one. The one we can test today.
Rotational clock effects. Since we established that c is a synchronization rate, not a constant speed, the local synchronization depends on the potential of the field. SGQM predicts that ultra-precise optical clocks should show synchronization-dependent frequency shifts. We are talking tiny shifts, delta f over f less than 10 to the 18. It's testable now. If we see those shifts, GR is wrong.
What else?
Gravitational wave anomalies. If gravity is a global readjustment and not a wave, the lattice has to settle after a massive event. We should see post-merger echoes. After two black holes collide, the Aetheron should ring like a bell settling into silence. GR doesn't predict that.
SGQM does.
LIGO has seen some potential noise in the post-merger signal, but it's controversial.
SGQM predicts high-frequency polarization shifts in that noise. It gives us a specific signature to look for.
And what about the constants? You mentioned alpha is geometric.
Yes. Variable alpha. In regions of extreme curvature, near a black hole event horizon, the synchronization of the lattice is stressed. The fine structure constant, alpha, should wobble. We might be able to see this in spectral lines from quasars grazing black holes.
If we saw variation in alpha, that would overturn standard physics overnight.
It would, and SGQM predicts exactly where to look.
All right, we've covered the theory, the mechanism, the knots, and the evidence. We need to wrap this up.
Let's do it.
Look, I come at this from a skeptic's point of view. The geometric unification is visually and mathematically stunning. The idea that everything, fermions, bosons, forces, are just different twists of the same geometry it's elegant. It cleans up the messiness of the standard model. But the non-propagation hypothesis, that is a tall order. It requires us to abandon our intuitive understanding of cause and effect traveling through space. It asks us to believe that the universe is a rigid, interconnected whole where separation is an illusion. That is a heavy philosophical price to pay.
I see why you think that, but let me give you a different perspective. The price we pay now is incoherence. We live in a world where we roll dice for quantum mechanics and curve smooth sheets for gravity, and neither talks to the other. We accept that because we're used to it, but it doesn't make sense. SGQM offers a universe where constants like pi, phi, and alpha are not random numbers we found. They are geometric necessities. It replaces the probabilistic view of quantum mechanics with geometric determinism.
Meaning physics isn't a roll of the dice?
Exactly. It's a rotation of the knot.
That is a poetic way to put it. And I will admit, looking for echoes in gravitational wave data and clock shifts, those are concrete steps. If those experiments come back positive, we aren't just tweaking the standard model, we are rewriting the book.
We are, and that's why this debate matters, because the source material suggests we're not living in a void. We're living inside a living geometric field.
It's certainly a fascinating possibility, and I'll be watching the clock data much more closely now.
Thank you for joining us on the debate. Keep questioning the nature of your reality.
And check your clocks.